Today we're going to be discussing hyperbolic functions. This is the first chapter in A2 Further Maths 9231 CIE, if you're wondering. So this we don't have much to go over. We just have about 4 or 5 things that we really need to look over. We just need to know what the hyperbolic functions are. We need to know how to sketch them. We need to know how to prove the identities and use the inverse of them, which is basically the bare bones of the entire chapter. And there's not much for it, so let's begin. So what are really our hyperbolics? Hyperbolics are based on e to the x. This is what makes up everything in this hyperbolic functions chapters. So the way you have sine, you have cos, you have tan, you have all these identities, the same way you have the hyperbolic counterparts. So the first one we have is sine x. This is e to the x minus e to the minus x over 2. Then you have cos. You should really try to not get them confused because they can be confusing. But yeah, this is e to the x plus e to the minus x over 2. Now these two are the fundamental ones because after them you can make up everything else. So the same way you have the reciprocal of cos being secant, the way you have here, let me write it down. So cos x is equals to 1 over sec x. The same way you have cos x is equals to 1 over sec x. Right, so this h determines and it tells you that, oh, this is not actually a trig identity or trig ratio, it's actually a hyperbolic ratio. It's not really a ratio, ignore that. But anyways, let's move on. Tan, that h tells you that it's hyperbolic. So the way we get tan is the same way we get tan. The way we would get tan would be sine over cos. So here it would have to be sine e to the x minus e to the minus x over 2. Now divided by, which is going to be 2 over e to the x plus e to the minus x. Now these 2's will cancel and we will get tan as e to the x minus e to the minus x over e to the x plus e to the minus x. Yes, you are required to know them, but if you know this one and this one, you can get every other one, so it's not really that hard to remember. Alright, so next one we can get, let's get sec. This is sec x. This is going to be the inverse, no, I mean the reciprocal of cos. So 2 over e to the x plus e to the minus x. I will leave a copy of my notes, not these ones, different ones, in the description, so you can follow through if you want to. Okay, so the next one is cosec. This is going to be 2 over e to the power x minus e to the power minus x, right? And the final one is coth x. This is going to be the reciprocal of tan x. So instead of the minus being on top, now we're going to have minus on the bottom. Yep, so e to the power x plus e to the power minus x, e to the power x minus e to the power minus x. And for this one, we do have a condition. X cannot equal to 0, I believe. Because if x is equal to 0, the bottom part, right, the denominator will equal to 0, and a fraction cannot be divided by 0. Or anything can't be divided by 0, so it cannot be equal to 0. And then it's the same here as well. X cannot be equal to 0, right? So you just have to make sure that all of this is followed, right? So this is like the first bit. That's the whole this thing completed. There's nothing much else to do about that. All right, let's move on to the second point, which is sketch the graphs. But before we do that, I would say that you should try and see if you can solve some hyperbolic equations, such as, let's say I ask you to find sine of 3. How would you do that? You would Well, first of all, you would have to do e to the power 3 plus, minus, e to the power minus 3, ignore that, and then over 2. When you do solve this, you get 10.02 and probably some other values as well. But this is what we get. You can do this manually, or you can go in your calculator and do it straight directly. Cosec of 3, which is just going to be 2 over e to the 3 minus e to the minus 3. And that is, we can first of all simplify this. If you notice, we can multiply both the top and the bottom by e to the power 3. Right? So this will give us 2 e to the power 3 over e to the power 6 minus 1. Now, you can do that if you want, but let's try to simplify this. Let's see what we get. Let me get 1 is 3. Okay, so here we get 0.0998. Right, that's the value of cosec 3, cosec of 3. Now you can do that for tan. Let's try another one. Tan of ln 4. Right, now if I write this out, what is it actually going to show as, like, in terms of e? It's going to be e to the power ln 4, right, minus e to the power minus ln 4, and then over e to the power ln 4 again, plus e to the power minus ln 4 yet again. The thing that makes them different, the denominator and the denominator, is the signs, the minus and the plus over here. Right, so when I simplify this, I could do it manually. Let's do it manually. So this is going to be, since this is e, right, and this is e and this is ln, we can just write 4 on top. There's no problem with that. And here, this is e, this is ln, but we gotta take this negative sign on top first, so we get minus 4 to the power minus 1. And the bottom is going to be the same thing. Well, the sign changes. Right, so when you do that, the next thing you can do is just simplify, or you could try to do what we did over here. You could multiply both sides, both bottom and the top, with 4, just so you have an easier time, but you don't have to do that. Here, you're just going to get 15 over 17. Now this is just a bit, extra detail. You don't really need to be able to do this. I mean, you should be able to, but you don't need to do this. All right, so next one, let's try to do something a bit different. So I have sin x. Now I don't know the value of x, but I know that sin x is equals to 5. What would 5 equals to? Now we would do something similar in trig, when we would say, well, I have sin x, right, and I want it to equal to 0.5. I can't equate it to 5 because sine is only from -1 to 1. Right, so for this I would say, well, x should be equal to sine inverse of 0.5, and then I would find my value of x. Here you can do that if you're using a calculator, but if it's manual, you can't exactly do that. What you would have to do is do it the long way. So e to the power x minus e to the power minus x over 2, which is equals to 5. Right, and we're looking for x. So now let's multiply both sides by 2, and we get e to the power x minus e to the power minus x equals to 10. Okay, now I can multiply everything by e to the power x just so I can get rid of this, because I don't really like that negative power. So let's multiply everything by e to the power x. So this becomes e to the power 2x minus 1, which equals to 10 e to the power x. And I'm going to bring everything to one side. Power x minus 1 equals to 0. Now, if you haven't noticed already, this is actually a quadratic, a hidden quadratic, like they say. So what I can say is either I could just do it directly, or I could make a substitution. Let's start with a substitution first. You could just say, well, y is equals to e to the power x. I say e to the power x because when I put y here, or I guess I can even show you here first. This is the same thing, minus 10 e to the power x. Right, so now if I put the y here, I get y squared minus 10y minus 1 minus 1, which gives me 0. Right, the direct method would just be to take this and just factor it properly, just factor it without having to make this step. Well, it doesn't really change anything. You can do that, you can choose to not do that. It's not really any different. All right, so when I do simplify this, I can use a calculator, I can use many different ways, you can choose anyone. I would get 5 plus minus root 26. Okay. Now, the negative counterpart, let me just write that as plus, is the problem with the negative part, which is this, is that it's less than 0, so that means it's negative. So when I do e to the power x equals to 5 minus root 26, this is not going to give me an answer, because I would basically be saying x ln of 5 minus root 26, like this, and while this part is negative, it's less than 0. So, and log or natural log of anything that's negative does not exist. So this one we can just ignore it, we can just reject it, right? That's fine. And then we can accept this one. So e to the power x will have to equal to 5 plus root 26, and then x will have to equal to natural log of 5 plus root 26. And that's going to be our answer. The first one, I want to draw y is equals to e to the x. The e to the x is a very simple graph. All you have to do is just make it, something like this. That's basically e to the x. So let's draw e to the minus e to the x. This is e to the x, but like negated. So it's just going to be like this, right? And then let's draw e to the minus x. This is just going to be all the x values negated. So like kind of like this. Something like that, right? And then now let's negate even that. So minus e to the power minus x. That will just be, nope, not like that. Right, it will be the other way. This way. Something like that. Okay, so those are the graphs. You don't really need to know them, but you should just have an idea of them, right? So let me begin by showing you the shine graph. Let me get some graphs in. Let's make y is equals to shine x. You're going to need to know how these work. So, and by the way, shine is an odd function. What that means is that it's not reflected by x equals to 0. So it's not reflected, perfectly along the x equals to 0 line. This is the x equals to 0 line, by the way, 0. So it's not reflected. But when you see something like, shine, when you see something like cosine, that is reflected. If you draw the graph out, you'll see that it is reflected by x equals to 0. And if you see something like sine x, it's not reflected. So therefore it is odd. But if it is reflected, it is even. Okay. So shine x is a very, very similar graph. We've seen something like this before. It looks like, actually, let me get a different color. Just like that. It should remind you of the tan graph. It should remind you of something like a cubic curve. All these things. It should remind you, and that it's very simple to remember. So that's just shine x. All right. So the next one is going to be cosh x. Let's write that down. Cosh x. Now this is an even function. This is even. So cosh simply looks like this. It looks like, hold on. Okay, I'll try to get a better graph for you, but this is how it looks like. It's just a sketch. And this place is 1, y equals to 1. So that's the lowest point in a Cauchy curve. This can be used to model a hanging chain, wires, all this sort of stuff. It should look similar to, minus x squared, y equals to minus x squared, but it's not. It's actually a hyperbolic function, so keep that in mind. All right, the next one is fan. Fan is interesting. Let's see how that looks like. So the fan has an asymptote over here. That's 1, and that's minus 1. So it has an asymptote, and it's 0 where x is equal to 0. So this is what fan looks like. Fan x is also an odd function. So these are just the basic ones, right? The sines, the shines, the cosines, the fans. The next ones are going to be the reciprocals, the cosec, the sec, the coth, all these. So cosec is simply like this, over here and over here. That is cosec. Y is equals to cosec x. Right, and this is also an odd function. Next one is going to be sec. Sec is very interesting. Some of you may recognize it. It's let me put a value here. That's 1. So sec is going to be like this and like this. If any of you remember, this is just a normal distribution curve, and it looks very, very similar. Obviously, it's not exactly the same thing, but it is very, very similar. This is sec x, and this is an even function because it reflects along x equals to 0. And the last one that we have left is going to be, let me make the asymptotes. Right, so this is going to be coth. Coth just looks like this, and this is an odd function. Okay, so now that we've gone over all this, you should just know how these look like. If they, all your knowledge from AS Maths about the transformation, all of that applies here. You should be able to do all of this. If they ask you to transform it, which is unlikely, but they can, so you should be able to do that. If they ask you to find a value of x and they give you a value of y, you can do that. You've seen how to do that. So I think that's really about it. So let's move on to the next bit. You said shine is equals to, I think it was 5 or something, right? And we said, oh well, what if we took the shine inverse of 5? Is there a function that just makes it easier for us instead of using the e to the power x, all the definition, the hyperbolic definition? Instead of using that, can we just find a function that makes this easy for us? This basically, because we don't really know what shine inverse is, right? We need to define it. The way we know what cos inverse is, tan inverse is, we don't really know what shine inverse is. So let's try to find a function for that, right? What we're going to do first is we're going to say, well, okay, f of x equals to shine x. Okay. Then we can say f inverse of x is going to equal to shine inverse of x. And obviously, y is still equal to shine x. Now, whenever you're trying to find the inverse, what do? You just flip the y's and the x's. So we're going to write the x outside and the y inside. Shine y. Now, then we get shine y, which should be equal to e to the y minus e to the minus y over 2. So x is really just equals to e to the y minus e to the minus y all over 2. And then let's multiply 2 on both sides, and then we get e to the y minus e to the minus y, and then we can multiply everything by e to the y, because we don't really need this one over here. So that will give us 2x e to the power y equals to e to the power 2y minus 1. So e to the power 2y minus 2x e to the power y minus 1 equals to 0. Brought everything to one side. Now we can complete the squares. If any of you remember, you take the first bit and you remove like the square power, which is, you know, this is the same thing as what we had written before. So we just keep this, and then we divide this by 2. That'll just be e to the power this, and we remove this one, by the way. So this is what we get. If you want, you can rewrite this. Let's say m is equals to e to the y, right? So that will be m squared minus 2xm minus m minus 1. So we can just do m minus x minus 1 minus so that will just be minus x squared. There's a square there. So m minus x minus 1 minus x squared, and that's still equal to 0. Now instead of the m, I'm going to bring back the e to the y because I think it's going to be a lot better, because we must see what's happening. And I'm going to take this bit, all of this, to the other side. Okay? Right, now I can take the square root of both sides. Let's take the square root over here, square root over there. So that's going to be me, well, e to the y minus x, which is equals to 1 plus x squared, and then under square root. Okay? Then I can take the minus x to the other side, and I get e to the power x. Let me just make more space. E to the power y, my bad, equals to x plus, don't forget there's a plus minus here, plus square root of 1 minus 1 plus, my bad, squared, and then that. Then y will simply be equal to natural log of x plus minus square root of 1 plus x squared. Now the problem with this is that x is always going to be, I guess you have to like kind of think about this in a different way. This bit, right, is always going to be bigger than this one. So if that is true, that means we can only allow a positive here. If it's negative, we cannot allow that. If you really want to know why that's the case, that's the reason. But if you don't, it doesn't really matter. So the answer is going to be x plus square root of 1 plus x squared. And that is basically what sine inverse is equals to. So this is the sine inverse, x plus root 1 plus x squared over, okay, and then natural log of all this. This is not the only one. We also have cosh, we also have tan, and I urge you to try and find cosh inverse, and tan inverse. But I will give you the answers over here. So pause the video and try to derive the cosh inverse and the tan inverse. But here is the real values. By the way, these are in the data booklet, so you don't really need to know them, but it's good if you do. So it's going to be natural log plus x squared minus 1. And the other one to be tan inverse of x, natural log, it's actually 1 over 2, natural log 1 plus x, 1 minus x. Very nice. And this one also has a condition. Positive modulus of x has to always be less than 1. So let's begin. You need to really know your trig identities here, right? And before we begin, I would like to point out a rule. It's called Osborne's rule. Is that for you to go from from trig to hyperbolic, the first thing that you have to do is turn all the sine x's to sine x's, and all the cos x's to the cos x's. And the second one is that if you see any explicit or implicit product of sines of two sines, if you see an explicit or implicit product of two sines, negate. So you just negate the sines or the sines to get sines. Right? So I'll give you an example. Basically, the example is if you have something like, sine squared x plus cos squared x equals to 1, the Pythagorean identity. Now you see here, sine x times sine x will give us sine squared x, and that is an explicit product of two sines. Now when I convert this to sine, right, this would be sine x plus cos squared x equals to 1. The only thing I have to change is here, I have to come over here and I have to add on a negative sign. This is very important. So now the hyperbolic counterpart of this identity is going to be this: cos squared x minus sine squared x, which is equals to 1. And this is a very important identity in hyperbolic functions. You should know this, even though it's given in the booklet. Okay, so this Osborne's rule is very, very important when you're trying to go from trig to hyperbolics, and you're going to have to do that a lot, right? Next thing is, the only thing that's left is knowing the identities. You don't really have to know all of them. You just need to keep in mind about this rule. This rule is very helpful, and you need to, the next thing that you need to do is be able to prove the left-hand side and the right-hand side. So let's give an example and see if you can do it. Okay, so here's an example. Prove cos 2a is equals to 1 plus 2 sine 2a. This looks very similar to the one that we have in the trig counterparts. I'm pretty sure it's cos 2a equals to 1 minus 2 sine squared a. Right, so now you've seen that here they've had to negate it. So it was minus before, so if you add another minus, that becomes plus. Right, so let's see. How would I go about this? Now, if I started from here, right, it would actually, in my opinion, be harder to show this. So this is one of the few rare cases where it's better to start from the right-hand side rather than the left-hand side. So let's begin. The first thing you would have to do is say that, well, sine a is e to the a minus e to the minus a over 2, and cos 2a is only going to be equal to e to the power 2a plus e to the power minus 2a over 2. So this is basically our target. Now we know what we're looking for. Okay, now they said 1 plus 2, right, 1 plus 2 times e to the a minus e to the minus a over 2, which is the sine, and then squared. Now you should be able to square this fairly easily. 1 plus 2 over 2 squared times e to the power 2a minus 2 plus e to the power minus 2a. Okay, so 1 plus, this is just going to be 1 over 2, e to the power 2a minus 2 plus e to the power minus 2a. So now look, we're trying to get here, right? And there is this e to the power 2a, e to the power minus 2a. We already have e to the power 2a and e to the power minus 2a. Let me first just group all of this together just so I have something going on, right? So e to the power 2a plus e to the power minus 2a over 2. And since I've multiplied, here and I've multiplied here, I have to also multiply here, which is just going to be minus 2 over 2. And that, well, that's just 1, right? And that's 1 over here. So 1 minus 1, that just goes away. So what we have now is cosh 2a. I hope that makes sense. That is basically all you have to do. These trig identities don't really get that difficult. You will understand them. And I can leave you a whole page of trig hyperbolic identities, which you can easily memorize if you want to. I don't recommend it, but if you want to. Alright, so I've gotten the hyperbolic identities. You can find them in the PDF below, so don't worry about that. This is probably way too much. You probably don't need all this, but if you want, try to prove all of these. Try to prove them. Try to see if you can get them right, and see if you know what you're doing. I would like to do one more question, however. This one says, I see this and I'm like, okay, there may be a quadratic that I can find. I see that there's a cosh here, there's a cosh here, okay, and there's no cosh here. Maybe they're hinting that, okay, you might have to go for a hyperbolic to quadratic route, which we can do. There's no problem with that. So let's try and see what we can do. I know that I can change this into, I can use the double angle formula for the cos counterpart, but I can turn it into cosh. So this is the formula if you're looking for it. So this is the formula if you're wondering, and we can just take this and just put it in there. So that will be 2 cosh squared x minus 1 minus 5 cosh x plus 4 equal to 0. Now, like I said before, I was hoping that this is going to be a quadratic, and it is, because you can already see that there's a squared term, there's a non-squared term, and there's a term that doesn't have this cosh at all. Okay, so this is the quadratic, and I'm going to factor it. When you factor it, you get I think it's going to be 2 cosh x minus 3, and then the other one is going to be cosh x minus 1 equals 0. So cosh x is equals to 3 over 2. Then cosh x is equals to 1. Now, remember what we did before. Cosh inverse 3 over 2, and then cosh inverse of 1. And both are equal to x. We've derived the formula for cosh inverse, right? It was, let's write this down again. It was x plus square root of x squared minus 1. So x is simply just going to be, it doesn't have to be x over here, it can be any value, by the way. We just wrote x, right? And then, right, so x is just going to be natural log 3 over 2 plus square root of 3 over 2 squared minus 1. And when I do simplify this, before I do that, let me get the other one done. That will be natural log of 1 plus square root of 1 squared minus 1. That will be natural log of 1, that's just 0. So x is just 0. Here, x will equal to, okay, I'm just going to see it on my calculator. That'll be 3 plus root 5 over 2. So that is the value of x in this equation. So it is a bit tricky. You do need to know your trig, because the trig will help you whether you like it or not. So go and learn your trig. You should know your trig identities. And then you should be able to convert them to hyperbolic identities, and then you should see how to solve stuff like this. It's going to be uncommon for them to ask you about stuff like this in A2. They're going to pair it with other things, so it's not going to be the main focus, but that does not mean they can't ask you. So if they do ask you, you should know how to do this, and it's very, very simple. It's basically the same thing as a trig function or an algebraic function, all those stuff. So it's pretty simple. I hope you understood. And yeah, so let's move on to the next chapter in a different video. Thanks for watching.